Hello everyone, welcome to another episode from Chedexcel. Today we are going to discuss the last part of the second chapter of Unit 1, that the variation of the electronegativity and the variation of the melting point. So we have discussed in two other videos how the atomic radius, ionic radius gets varied, and how the first ionization energy and the successive ionization energy value varies. So today the last part of that periodicity part, that is how the variation of the electronegativity and the melting point of a substance differ depending on their position of the periodic table. So this will conclude the second chapter of Unit 1, right. So if we talk about the electronegativity part first, right. So let's say what is electronegativity. So electronegativity, we have a definition that commonly asked there as well, especially this electronegativity asked in Unit 2 paper, but we need to know what it is because we need this idea for the third chapter. So electronegativity is the ability of an atom to pull electrons towards that element when it is present in a covalent bond. So simply, the ability of an atom to pull electrons when it is present in a covalent bond. Now the idea of this ability to pull electrons, so to pull electrons normally makes the negative ions. So when you talk about the periodic table left to right of a period, right, we know that non-metallic nature increases. So when the non-metallic nature increases, that makes the electronegativity to increase as well. So generally left to right of a period electronegativity increases. Then what about the top to bottom of the group? Top to bottom of the group, metallic nature increases. So if the metallic nature increases, their ability to pull electron decreases, or other way around you can say their electronegativity decreases. So generally if you talk about the electronegativity, what we say is electronegativity increases left to right of a period, electronegativity decreases from top to bottom of a group. Why is that? Because down the group the radius increases, so the nuclear attraction decreases, so we say the ability to pull an electron decreases because the nuclear attraction decreases. So the other thing is the metallic bond doesn't tend to form negative ions, metals always tend to form positive ions, so the electronegativity mainly decreases in that manner as well. So what you have to remember is electronegativity increases from left to right, decreases from top to bottom. We have a scale for the electronegativity, we call it as the Pauling scale, but you don't have to remember the values or the digits or anything. Just to remember, electronegativity increases. Now group 8 elements or group 0 elements, we call them as noble gases, and they do not tend to form compounds, so that we can't define an electronegativity value for the outer group 8 or group 0 elements. So we don't have an electronegativity value for helium, neon, argon, krypton, xenon and radon. So in that case, highest electronegativity element would be fluorine. Fluorine has the highest electronegativity, right. So the idea you have to remember is electronegativity increases left to right of the group, electronegativity decreases from top to bottom of a group. Having that thing is enough. We need that one for the third chapter when you talk about the bonding and the polarization, those stuff we'll see. The last one is melting point. How the melting point of a substance get varied. Now the melting point of an element mainly depends on their structure and bonding, we say. So depending on the structure and bonding, the melting point varies. So if we talk about the type of elements we have in the periodic table in group wise, so group 1 to group 3, group 1, group 2 and group 3, we mainly have metals. So we say them as they have metallic bonding. So now still we haven't discussed about the bonding part comes to the third chapter. So this is like just the introduction for the third chapter as well. So group 1, group 2, group 3 have metallic bonding. What about group 4? Group 4 have covalent bonding, but it's giant covalent, they are structure type, giant covalent. What about group 5, group 6 and group 7? They have simple molecular structure. So they have the simple molecular structure. When you talk about the melting point, we are going to look at how easily the particles involving can be separated by supplying heat. So when it comes to the metallic bonding, group 1, 2 and 3, group 1 is the most soft metals, group 2 has more delocalized electrons, group 3 has even more. So the metallic bond strength is greater in group 2 than group 1 and highest is in group 3. So aluminum has more stronger metallic bond than group 1 and group 2. So when you talk about the metallic bonding, group 1 to group 3, generally from left to right of a period, we can say the metallic bond strength increases, hence the melting point also increases. When it comes to the group 4, they have giant covalent structures, something like graphite, diamond, silica, like that. They have very high melting points. In fact, the melting point of diamond and graphite is much higher than the metallic bonds. So the melting points of group 1, 2 and 3. So we always say group 4 has the highest melting point. So diamond, silicon, they all have very high melting point. Now when it comes to the group 5, 6 and 7, again they have simple molecular structures and the strength of the bonds, the molecules decreases time, and their forces of attractions also gets decreases. So what normally happen is we have to supply less amount of energy to break the structure of group 5, 6 and 7. Last one is group 8. Group 8 means noble gases. They do not tend to form molecules or the compounds at all, so that they don't have that much of melting point. In fact, all of them are gases. They have very low melting point. Okay, so in that manner, if you talk about group 1, 2 and up to group 8, group 1, 2, 3 has increment and group 4 has the highest, 5, 6, 7 it decreases and 8 has the lowest. So if you just draw the graph, it would appear like this. So normally this is for group 4. If this is the melting point axis, and this would be the atomic number or the group number, let's say. Group number, we would see group 4 has the highest, group 8 or group 0 has the lowest. So that is the only thing to remember in this one. This is a very common one. They ask in MCQs, given 4 elements, which one has the highest melting point. So that is the thing, right? So this covers the second chapter of unit 1, and then we have to start chapter 3. So this is a part 3, and I'll put a link. You can watch the previous 2 parts as well. So if this is helpful, give us a thumbs up and consider subscribing. Thanks for watching.